one very important point when we want to start a test with soil organisms is to adjust the soil moisture. For that point, we should take into account the soil properties, namely the texture and the organic matter content. For instance, a soil with a coarse texture has larger particles, which means that has the ability to retain a certain amount of water that is less than if we think on a soil with fine texture, that has fine particles and has higher ability to retain more water. The same happens with the organic matter content of the soil. A soil with a higher organic matter content has more ability to retain water than a soil with low organic matter content. Well, to make this correction of the moisture, we should take into account a certain amount of water that is related and highly dependent on the maximum water holding capacity of the soil. What does this concept mean? The water holding capacity is the maximum amount of water that one soil is able to hold. What does this mean? This value is usually expressed in a percentage. For instance, if we have a soil with 30% of water holding capacity, this means that 100 grams of soil is able to hold a maximum of 30 milliliters of water. How can we measure this concept and how can we measure the water holding capacity? So, how to measure the water holding capacity of a soil? We have here an artificial soil as an example to measure it. So we use these glass crucibles. Ideally we should use 3 replicates to measure it. So these glass cylinders are open in the top and in the bottom has a filter with a certain porosity that's able to retain the soil inside of the cylinder and let the water enter from the bottom to the top. Okay, so we start by filling the cylinder with soil. I will do it here. It doesn't matter if the soil is dry or with some moisture. It doesn't matter because we want to saturate the soil. Okay. Usually we fill the cylinder until more or less 1 centimeter from the top, and then once we have it filled, we should put it inside of a glass or a container, and the idea is now to saturate and to flood the soil with the water. So we should fill the container from outside with water, because the idea is to allow the water enters in the soil but from the bottom to the top. So we should fill the water but not higher, in a level not higher than the top of the cylinder, in order to force the water entering from the bottom. So as you can see, the water is entering in the soil column from the bottom to the top. Okay, once the water reaches the top of the soil, we should leave the soil here, flood it with water during 3 hours. So we have filled the 3 crucibles. After the 3 hours in a container with water, we remove the crucible from the water and we put it in a tray with a net in the bottom. The idea is to let goes down the water, the gravitational fraction of water in the soil. So they are left in the top of a net that is in the bottom of these boxes. And they should be here for 2 hours. And during these 2 hours, we should cover the box in order to avoid losses of water by evaporation, because we want to lose the water only from the gravitational fraction. So we leave it for 2 hours. So the last step now, after this 2 hours period, we should dry the soil. And for that we should transfer the crucibles to an oven, because the soil should be kept at 105 degrees for at least 12 hours. So we should transfer the crucibles to the oven, turn it on, set the temperature should be at 105 degrees and leave it for at least 12 hours. So after the whole method we should record 4 values from each replicate. First of all, we need the tare, the dry tare, the weight of the crucible with the filter dry. Okay, this is the early beginning. After then we have to moist the filter and wait again, so we need the wet tar. So the second value is the weight of the crucible with the filter wet. Third value should be the soil saturated when we after the first 3 hours period, after the second 2 hours period, when we lose the gravitational fraction of water. And lastly, we should wait the soil after the 12 hours in the oven at 105 degrees with the dry soil. These are the 4 values that we should take note from each replicate. So now let's try to understand the accounts that we have to do to adjust the soil moisture for a test. Giving an example of an avoidance test with earthworms using as test substance salt, the NaCl. It is a relevant stressor in the environment, so we will use it as an example in this case. So, starting by an OECD standard test, we know that the water holding capacity of the soil is more or less 50%. So let's assume a 50% of the water holding capacity of our soil. This means that 100 grams of soil is able to retain 50 milliliters of water. Well, according with the protocol, we should use a soil moisture that corresponds to 50% of the water holding capacity of the soil in the tests. This is a good moisture to the test organisms that we want to use. This means that we have to have a soil with that has 100 grams of soil. It should retain 25 milliliters of water, which is half of the maximum that the soil is able to retain. Okay, so 50% of the water holding capacity is half of the maximum water holding capacity. That in this case corresponds to 100 grams of soil with 25 milliliters of water. The chemical that we will use is salt, the NaCl, and the concentrations that we want to test is always combining control soil with 1 gram of salt per kilogram and another concentration that is 0.5 grams of salt per kilogram of soil. To prepare these treatments, we prepare the stock solution of 4 grams of salt per liter. Okay, so an avoidance test. Each replicate is composed by a box divided in the middle and that to have 2 sections, equal sections. In one side we will have our control soil and in the other side we have our test soil. That is a soil with a content of salt. So in each side we should have 250 grams of soil. So regarding the salt content, first, if we want our first concentration, that is 1 gram of salt per kilogram, so we should have 1 gram of salt per kilogram of soil. This means that in 250 grams of soil we should have 0.25 grams of salt. Okay, this is for this concentration. If we want half concentration, that is our case 2, that is 0.5 grams of salt per kilogram of soil. This means that in 250 grams of soil we should have 0.125 grams of salt. Okay, so we already have our salt content in each treatment. Now we need to calculate the water content for each side. Water content. Okay, in this case, since we want this relationship, I mean in each 100 grams of soil we should have 25 milliliters of solution of water or salt solution. Depends on the treatment that we are preparing. So we want to keep the relationship between 100 grams of soil with 25 milliliters. In this case, if we want 250 grams of soil, that is the amount of soil in each section of our replicates, we need 62.5 milliliters of water. Okay? Water or salt solution. That is what we have to see now. Okay, since we have a stock solution with 4 grams of salt per liter, we will need to make a proportion. So we have 4 grams of salt in 1000 milliliters of solution. This means that if we want 0.25 grams of salt, that is what we need in our first treatment, we need a certain volume of solution, and this volume should be 62.5 milliliters of stock solution. This is exactly the amount of water that we need to have in the amount of soil that we want to fill one of the sections of our replicates. So it's perfect in this case. This is for the first case. Okay? If we want the second concentration, we will need to have half salt because we want 0.5 grams per kilogram of soil. In this case, we need to have 0.125 grams of salt. In this case, how much we need of stock solution? In this case, we need exactly half, that is 31.25 milliliters of stock solution. So we have exactly the amount we need of stock solution for each part. So for the first case, we need to have 250 grams of soil. We will have 62.5 milliliters of stock solution. For the second concentration, we will need to have 250 grams of soil plus 31.25 milliliters of stock solution plus the same amount of water. because we need to have the same moisture in both soils. And finally, in our control, we need 250 grams of soil plus 62.5 milliliters of water. By this way, we will have our 3 treatments with the same moisture each and with different concentrations of salt in our 2 treatments of test soil. Okay, so now we will start to prepare our replicates. As an example, we will show how to prepare one replicate of the combination between control and the treatment corresponding to the concentration of salt of 1 gram per kilogram of soil. First of all, we have our box. We should label it. It is very important to know exactly which soil we have in each section of the replicate. Therefore, we should start to divide the replicate in order to know exactly where to insert our card divider in the box when we want to finish and start the tests, and then write the soil that we have in each side of the replicate. Okay, and then the number of the replicate, and that's it. This is sufficient. Okay. So now we will weight batches of soil, 2 batches of soil of 250 grams each one, because it will be the soil that will be for each section of the replicate. So we should weight, we have our OECD soil, and we should weight 250 grams of soil in a tray, then to mix it with the solution or the water that we want. Okay. So almost done. 250.
Yes.
So we already have 2 batches of 250 grams of soil each. We have our stock solution made by salt, with salt and water, and we have the distilled water to add in our control. And now we are going to mix our solutions and the water in the different batches of soil to compose our replicate. So let's start by the control. So we will measure using a cylinder, we will measure the 62.5 milliliters of water, because the control only have water, is a clean soil. So 62.5 milliliters of water. We have it in the 250 grams of soil, and we should mix everything very well. The soil should be completely homogeneous. The water should be mixed very well in the whole soil. Okay, when we have the soil is homogeneous, it is ready to have in the replicate in the side of control. Okay, so let's put it here. So the divider is already inserted in the box, and the soil is added to the section, the control section. Here. Okay. have our control side ready. Now we will prepare the soil with 1 gram of salt per kilogram. So we will need 62 milliliters, 62.5 milliliters of stock solution to have in the 250 grams of soil. So we will add some stock solution to a beaker and then measure the stock solution in our cylinder. 62.5 milliliters. Done. Then we should add it to the soil and mix it very well as we did for the control soil. So we should mix it also very well. Here we should mix it for two reasons, not only to distribute homogeneously the moisture in the soil, but also to spread very well the contaminants in the soil. Okay, once the soil is well homogenized, we are ready to add it in the replicate. Okay, so let's do it once more. We should take into account that we are adding the soil in the right section of the replicate, and let's do it. The divider remains inserted because we still don't want to mix both soils, both sections of the okay. That's it. And done. So we have the replicate with the two sides filled with its respective soil. Then finally we should remove our divider, mix and tap just to avoid space between the two soils, and we have the replicate ready to add the test organisms in the middle of the box. Okay, so now we have to transfer 10 test organisms, earthworms, to its replicate. So we keep our laboratory cultures in a substrate composed by peat and cow dung. As you can see here, our earthworms, this is one of our culture boxes. We have here our earthworms. Check. I think it is already possible to see them. I will put some in my hand just to make easier to see them. Okay, so we should take this species is Eisenia andrae, is one of the most used earthworm species in soil ecotoxicology, is Eisenia andrae, and we should select 10 earthworms and introduce them in each replicate. Okay? Okay, so I already selected 10 earthworms, 10 individuals for each this beaker. Okay. Now each one should be washed, dried, washed and dried. Okay, there are some ones right here. We should be very careful to do not damage them. If that happens, we should change the organism because we only want healthy organisms. So we have our 10 earthworms here washed and dried. One more. We have our 10 organisms that should be inserted in the middle of the box. In the middle, exactly in the line between the two soils. Control soil and test soil. Then we should close our replicate. Okay, and we should wait 48 hours, after which we finish the test by inserting again our divider and counting the number of earthworms in each side of the box. Okay, as you can see, the earthworms are completely buried. This is the end of the test. Okay, so we will finish after starting 48 hours before. So we open the replicate and let's finish the test. So usually what we do is we reinsert the divider. Okay, we try to separate both sections of the soil in order. The divider should be inserted to avoid the movement of the organisms for one or other side. If we find an earthworm in the middle, that earthworm should count half in each side of the replicate. Okay. Then we should remove one of the sections to the tray in order to take all the earthworms of this side to the tray, and the number of organisms will be counted. Okay, so in this side we have our test soil in the tray, and here we remain the soil, the control soil, okay, and the earthworms. So and now it's easy, just counting the earthworms carefully. So we have 1, 2, probably we will find more in the control, 2, 3, because this control soil doesn't have salt as in the other. 3, 4, 5, 6, 6 earthworms here. Sometimes 6, 7, another one. So out of 10 we have 7 earthworms in the control, and then we should check also in our test soil if we have the other 3. 1 is here, 2 and 3 earthworms. So we found 7 earthworms in the control side and 3 earthworms in the test side.